Welcome, fifth graders. Today we're going to do Chapter 6 review. As we go through this, there are a few questions that we are going to skip because we skipped those lessons during this chapter. So we will just cross those problems out. You may want to press pause after we read each question to see if you want to work those out on your own, or you can just continue to watch and fill it in as we go to prepare for your test tomorrow. As we go through this, question number 1 is from the estimation lesson. We have skipped that lesson, so you can go ahead and cross off number 1, as well as question number 2. We skipped the patterns question and the properties. Question number 3, you can also skip on there, as well as question number 4. So we're skipping questions 1, 2, 3, and 4. All right, as we start here, we're going to start with question number 5. It says, write 2/5 and 1/3 as equivalent fractions using a common denominator. Now, it doesn't say least common denominator, so there are a few options. When you get to your test, there will be only one correct option, so you may have to list a few. Most of the time, it's going to be the least common denominator. So when we're doing common denominators here, we're thinking using 5 and 3, and we're listing the multiples. So we're thinking 3, 6, 9, 12, 15, 18. We're counting by 5s, 5, 10, 15. 15 is the least common multiple, so we're going to use that as the least common denominator. So we're going to turn 2/5 into 15, and we're going to also turn 1/3 into a 15 here. 5 times 3, so we will also do whatever you do to the bottom, you do to the top. So we get 6/15. 3 times 5 gets me 15, so I do 1 times 5, and we get 5/15. So the least common denominator is 15, and we made equivalent fractions there with 15 as the denominator. You could have also used 30, since it doesn't say use the least common denominator. They would have given you 12 over 30, as well as 10 over 30, and those would have also been equivalent to 2/5 and 1/3. So when they want you to find common denominators, just use multiples, count by those numbers until you find a number that they have in common. Question number 6. Jill brought 2 1/3 boxes of carrot muffins for a bake sale. Mike brought 1 3/4 boxes of apple muffins. What is the total number of boxes of muffins Jill and Mike brought to the bake sale? So because we want to find total, we are going to add these two together. So we're going to do 2 1/3 plus 1 3/4. First step is always to find a common denominator. So I count by 3 and count by 4 until I find one that they have in common. It would be 12. That's the least. Then I ask myself, 4 times what gets me 12? 4 times 3. Whatever I do to the bottom, I also do to the top. So I get 1 and 9 twelfths on the bottom. 3 times 4 gets me 12, so I have to do 1 times 4. And that gets me 2 4 twelfths. Now I'm going to add those two together. 4 plus 9 gives me 13 twelfths, and 2 plus 1 gives me 3. Because 13 twelfths is an improper fraction because the top is bigger than the bottom, we have to divide this. We have to use TIBO, where we put the top number inside and the bottom number outside. 12 goes into 13 once, then we subtract. We put the 1 on top from our remainder, and 12 goes on the bottom. Don't forget to add the 3 to the 1 here, and our answer is 4 and 1/12. So remember, on those kind of problems, when you get an improper fraction, you just have to divide. Sometimes students will do that in their head, which is just asking themselves how many times 12 goes into 13, and then subtract them and make that as a fraction. Or you can use TIBO, where you actually divide it, put the top number inside, bottom number outside, and then just work the problem like we did. Always make sure that you add your whole number at the very end so that you don't miss the problem. Question number 7. The shaded part of the diagram shows what Jeannie has left from a meter of string. She will use 3/5 meters of string to make bracelets. She wants to determine how much of the string she will have remaining after making the bracelets. Well, first we need to figure out how much does she have. If the whole thing was 1 meter, then we have 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 10. So we have 9/10 of a meter to start with. If she uses 3/5 of a meter, she's going to be taking that away. So question 7a says to determine how much string will be left after making the bracelets, Rebecca must find 9/10 minus 3/5. That is correct. That is a true statement. She's going to start with 9/10. She's going to take away 3/5. So yes, we are going to start out with 9/10 minus 3/5. Part B then says the fraction 3/5 and 6/10 are equivalent. Well, what they're asking is, the next step says always to find a common denominator. Well, if I count by tens and I count by fives, they both can turn into 10. So 10 is our least common denominator. The question was, is 3/5 equivalent to 6/10? Well, to figure that out, we just figure out 5 times what gives us 10, and that's 2. And whatever we do to the bottom, you must do to the top to keep it equivalent. 3 times 2 is 6. So yes, 3/5 can turn into 6/10 because they are equivalent. They are equal to each other. The last part here says Rebecca will have 1/5 meter of string left. Well, what we need to do then is finish the problem here, 9/10 minus 6/10 to determine how much she will have left. 9 minus 6 is 3 over 10. 3/10 does not simplify anymore, so the answer is 3/10. It is not 1/5, so that is false. So for this one, you just set the problem up. You're going to go ahead and subtract to figure out how much was left. Obviously, when they're talking about being equivalent there, they're just talking about going from this step to this step here to see if those fractions do turn into each other. Question number 8, you can skip because we did not do the properties question in the textbook. As well as question number 9, we skipped the patterns lesson, so you can cross off question number 9. On the next page, we're also going to cross off question number 10 and number 11. So we've crossed off quite a few here on the first couple pages. We'll have quite a few more here once we keep going. So go ahead and turn to question number 12. And question number 12 here says, Alana bought 3/8 pounds of Swiss cheese and 1/4 pound of American cheese. Which pairs of fractions are equivalent to the amounts Alana bought? So we are basically turning 3/8 and 1/4 into each of these denominators here. So we need to turn 8 and 4 into 16, into 32, into 40, and into 64, and see if all of them work out. So we'll just go ahead and start here. 3/8 and trying to turn that into a 64. And then we're going to turn 1/4 into a 64. To keep it equivalent, whatever I do to the bottom, I must do to the top. So for 3/8, we multiply this by 8. And whatever I do to the bottom, I'm going to multiply the top by 8. That would be 24. That does match. 4 times 16 gets me 64. So I do 1 times 16, which is 16, which gives us a fraction of 16/64. It's not really easy to read there because of the small space, but 16/64. This is not 16/64. This is 8/64. So it is not equivalent. For B, we're going to turn 3/8 into a 16, and we're going to turn 1/4 into a 16. 8 times 2 gives me 16, so I have to do 3 times 2, which is 6. That matches. 4 times 4 gives me 16, so I do 1 times 4, which is 4. And this is 4/16, which also matches, so B is equivalent. 6/16 and 4/16 are equal or equivalent to 3/8 and 1/4. We'll continue on. 3/8 and 1/4 trying to turn into 32. We're going to do 8 times 4 to get 32, so we do 3 times 4, which is 12. 4 times 8, so I do 1 times 8, which is 8. The 12 30-seconds matches, but 6/32 is not 8/32. It should have been. So this does not work. You don't want to fill that in. It does not work here. For the last one, we have 3/8 and 1/4 turning into 40, this time as the common denominator. 8 times 5, so we do 3 times 5, which gives us 15/40. 4 times 10, so I do 1 times 10, which is 10/40. 15/40 and 10/40 are equivalent. D is also a correct answer. So in order to find equivalent fractions, just figure out what did I multiply the denominator by and do the same to the numerator. On the next question, 4 students spent time volunteering last weekend. The table shows how much time each student spent volunteering. Match each pair of students with the difference between how much time they spent volunteering. So first, we know difference means we are going to subtract. So we need to subtract each of those names here, Amy and Victor, Cal and Beth, and then Beth and Victor, and see which one of those it matches up with. So we're going to subtract Amy, which is 4 5/6, and Victor, which is 5 3/4. Victor is going to go on top because his is a larger number. Minus 4 5/6. The first step is to find a common denominator. If I count by 6s and count by 4s, we know that the common denominator is 12. So we do 4 times 3, and I do 3 times 3, which is 9. I do 6 times 2, so I do 5 times 2, and we get 10. So we have 4 and 10 twelfths and 5 and 9 twelfths. Well, when we subtract here, 9 minus 10 you cannot do. So we have to borrow from the 5. So I'm going to cross off the 5 and make it a 4. And I'm going to add the common denominator of 12. We're going to add 12 twelfths. This should give us 9 plus 12, which is 21 twelfths. And our whole number is now 4. 4 and 10 twelfths just comes over with it. And then we're going to subtract. 21 minus 10 is 11 over 12. 4 minus 4 is nothing. 11 twelfths is what Amy and Victor work, the difference between their 2 times. So we connect the lines there. We're going to go ahead and erase and work the next group here. And we really only need to work the next one because if it works out, then we know what the last one is. Cal and Beth. Cal is 5 2/3. Beth is 6 1/2. So Beth goes on top. Cal's amount, 5 2/3, goes on the bottom. And then we subtract. Again, we have to find a common denominator, counting by 3s, counting by 2s. We don't have to count very far because they both can turn into 6. 2 times 3 gets me 6, so I do 1 times 3. 3 times 2, so I do 2 times 2, which is 4. Now I can subtract. 3 6 minus 4 6 we can't do because again 3 6 is smaller than 4 6, so we have to borrow. The 6 becomes a 5. This time our common denominator is 6, so we're going to add 6 6. Now remember, we're adding this to it, so we're doing 3 plus 6 gives us 9 6, and then we bring the 5 and 4 6 over. 9 6 minus 4 6 is 5 6. 5 minus 5 is 0, so we are done. The answer is 5 6. Cal and Beth had worked a difference of 5/6 of an hour. We do know that this last one should work out. Beth and Victor should be 3/4. We're going to go ahead and solve anyways, just to be on the safe side here. Beth is 6 1/2. Victor is 5 3/4. Common denominator for these two is 4, so that does not change the 5 3/4 at all. 2 can turn into 4 by multiplying by 2. Do the same to the top. 6 2/4. Go ahead and subtract. Again, 2/4 minus 3/4 can't do. So we borrow from the 6, make it a 5. Add 4/4 because that's the common denominator. That gives us 5 6/4 minus 5 3/4. 6/4 minus 3/4 is 3/4. 5 minus 5 is 0. 3/4 is our answer. And Beth and Victor worked the difference of 3/4 of an hour. Number 14, tell which expression requires you to rename mixed numbers before you can subtract. We're going to go ahead and scratch this out, and you do not need to find the difference. You're just going to write each expression inside the box. You do not need the difference here. All we're doing here is we're looking for which ones do you need to rename, which is just a fancy word for borrow. So all we have to do for 14A, B, C, and D is set the problems up and decide, do you have to rename or borrow, or can you just go ahead and subtract? If you need to borrow, you put it in the requires renaming. If you do not have to borrow, then obviously it does not require renaming. So just set up each equation or expression here and find a common denominator. When you're ready to subtract, decide, do you have to borrow or not? First one, this is 14A, 2 1/3 minus 1 3/4. Find a common denominator, which is 12, times 3 to get there, times 3, times 4 will get me to the 12, so I do 1 times 4. If I look at this here, even before I add my whole numbers, I can see that 4/12 minus 9/12 is not going to work out, and we're going to have to borrow. So we're going to put that in the renaming category. We are going to have to rename this mixed number in order to subtract. So we're going to write 2 1/3 minus 1 3/4. On your test tomorrow, you will just have to grab the box there and drag it into this renaming box here. 14B, 1 3/4 minus 7/8. Again, find a common denominator before we can add or subtract or do anything with these fractions. So the common denominator, count by 4s, count by 8s. They both can turn into 8 times 2. Do the same to the top. That would be 1 6/8. So then we look to subtract 6/8 minus 7/8. Again, we cannot do this, so we would have to rename this mixed number or borrow. So we're going to put that in the requires renaming box. 1 3/4 minus 7/8 would require us to rename that mixed number. 14C, 5 2/3 minus 2 5/8. Find a common denominator, counting by 8s, counting by 3s. They both can turn into 24. 3 times 8 and 2 times 8 is 16 24ths. 8 times 3, 5 times 3 is 2 15 24ths. If we look to subtract 16 24ths minus 15 24ths would work without borrowing. So therefore 14C is going to go into does not require renaming. And then the last one, 6 1/5, 2 1/3. Setting that one up, again, find your common denominator. This one is 15. 5 times 3, so I do 1 times 3, 3 times 5, 1 times 5. Does not look good for our subtraction here. 3/15 minus 5/15 you can't do. You would have to borrow from the whole number. So that's going to require our renaming. So we're going to put the 6 1/5 minus the 2 1/3 in the requires renaming box. So for question number 14 on your test tomorrow, set the problems up, get ready to subtract, and right before you subtract, decide, can you just subtract them because it works? Or do you have to rename the fraction by borrowing from the whole number? Last page here. Question number 15. Mr. Clements painted his barn for 3 3/5 hours in the morning. He painted the barn for 5 3/4 hours in the afternoon. Select true or false for each statement. Well, we have 3 3/5 in the afternoon and 5 3/4, or 3 3/5 in the morning, 5 3/4 in the afternoon. The question A says a common denominator of the mixed numbers is 20. Well, if I counted by 4s and I counted by 5s, could they both turn into 20? They would be, 20 would be the least common denominator, so that does work. So that is a true statement. The amount of time spent painting in the morning can be rewritten as 3 15/20. Well, again, find your common denominator. Times 5 times 5. That would be 5 15/20 times 4 times 4. This would be 3 12/20. Remember, the 3 3/5 was in the morning. That turned into 3 12/20. So no, that is not equivalent. It cannot be written or rewritten as 3 15/20. The last part says, part C, Mr. Clements spent 2 3/20 hours longer in the afternoon than in the morning. So we want to know what's the difference. The difference here. Well, in order to find the difference, we're going to subtract these two. But we're not in any position right now to subtract them because 5 15/20 has to go on top. And 3 12/20 have to go on the bottom because it's the smaller number. Now that we've stacked that up with the larger number on top, 15/20 minus 12/20 is 3/20, and 5 minus 3 is 2. So that is a true statement. He did spend 2 3/20 hours longer painting in the afternoon than he did in the morning. Question 16 has 3 parts here. Tom exercised for 4/5 hours on Monday and 5/6 of an hour on Tuesday. Complete the calculations below to rewrite equivalent fractions with a common denominator. So, what they're trying to get you to do here, and on your test tomorrow, you will have to drag different numbers to go into these boxes. But what we're trying to do is first take 4/5 and 5/6 and come up with a common denominator. So if we're counting by 5s and we're counting by 6s, the first number that would be in both lists would be 30. 30 is our common denominator. So we're going to place the 30 in the bottom right because that is our new fraction that we're trying to make. The 2 boxes before that are basically what we do on every problem. What do I multiply the 5 by to get 30? We do 5 times 6 to get 30. And whatever we do to the bottom, we must also do to the top. So remember, when we're multiplying the bottom and the top, remember that's just like a fraction with the same number on top as the bottom. We do then 4 times 6 and we get 24. On the 5/6 here, we do 6 times 5 to get that 30. So we have to do 5 times 5 to get an equivalent fraction. 5 times 5 is 25. So 4/5 turns into 24/30. 5/6 turns into 25/30. Now we're going to use these two fractions here, now that we have common denominators, and we're going to answer part B and C. How much time did Tom spend exercising on Monday and Tuesday combined? Combined means we're going to add these two fractions together. So we would take 4/5 plus 5/6. Now we already have the common denominator, so we're going to do 24/30 plus 25/30. We're going to add those two fractions together. If we add those two fractions together, 25 plus 24 is 49/30, which is an improper fraction. And when we have an improper fraction, we need to T-bow this. So we're going to take 49 divided by 30. The top went inside, the bottom went outside. Now we can divide it. 30 goes into 49 once. When I subtract, I get 19. That 19 becomes the numerator, and 30 stays the denominator. So he worked for 1 19/30 hours. That's how long he exercised. Part C. How much longer did Tom spend exercising on Tuesday than he spent on Monday? And again, our explanation here is just going to be using our work to show us, show how we solve this problem here. So again, on Tuesday, he worked out for 25/30. On Monday, it was 24/30. So if we want to figure out how much longer, we're going to take those two numbers and subtract them. Once we have the common denominator, which is what we found at the top, when we subtract, we just subtract the numerators. 25 minus 24 is 1. 30 stays the same on the bottom, and our answer, the difference between these two, he worked 1/30 hours longer on Tuesday than he worked out and exercised on Monday. This ends today's lesson. Great job today. If you guys have any questions, please feel free to reach out. Your test is over chapter 6 tomorrow. These questions will be very similar to what we did today. If you need help, go back through the video. If you're still having issues, you may reach out to Mrs. Laudick or I. Good luck studying, and have a great day.